At some point in the last few months, something changed in the space around Earth, and scientists can't explain what. We tracked this story from the beginning. A 7-ton rock detonating over Ohio with the force of 250 tons of TNT. A meteorite through a Houston roof. A statistical deviation so extreme that scientists stopped using the word unusual and started using the word anomalous. We asked what they weren't telling us. At the beginning, we thought we were watching an American anomaly. We were wrong. Brandenburg, Germany, then New Zealand. Not one city, not one country. 3 continents at minimum. The Anthelion zone, the sky directly opposite the sun, has doubled its historical activity with no identified source. An interstellar object passed through this exact region of sky 5 months ago. In 3 days, a comet from one of the most dangerous comet families reaches the sun. Nobody is connecting these dots officially, but tonight, we finally connect them. Stay until the end. Hit subscribe and stay close, because this story is not finished. The fireballs are still falling. The Anthelion zone is still elevated. The comet reaches the sun in 3 days, and what happens in that window is something we will be watching in real time. This channel has been here since Ohio. We will be here for whatever comes next. You will want to be here too. Now, let us get into it. Something photographed itself over Brandenburg, Germany, on March 23rd, and it didn't ask permission. A fireball, bright enough to be captured on camera, energetic enough to generate reports across Central Europe, lit up the sky over one of the most densely monitored regions on the planet. And here's what made it strange. It wasn't supposed to be there. Not because fireballs don't happen over Germany. They do. But because this one arrived at the exact moment that a pattern we had spent weeks treating as an American story suddenly revealed itself to be something much, much larger. Then, 7 days later, on March 30th, the American Meteor Society logged a fireball report from New Zealand, Southern Hemisphere, opposite side of the planet. And just like that, the assumption that had quietly anchored every conversation about this surge, the idea that something strange was happening over the United States, didn't just shift, it collapsed. Let me take you back, because this channel has been tracking this from the beginning, and you need to understand what the beginning actually looked like. We covered the Ohio event first, a roughly 7-ton object that entered the atmosphere and detonated with the equivalent force of approximately 250 tons of TNT. Nobody saw it coming. That is not a figure of speech. The detection infrastructure in the state of Ohio had one all-sky camera active in the relevant coverage zone, and it was offline when the event occurred. We covered the Houston meteorite, the one that punched through a residential roof, which is the kind of sentence that sounds like a headline from a supermarket tabloid until you realize it was confirmed by the American Meteor Society and investigated by actual geologists. We covered the Michigan double fireball event, 2 separate energetic objects in the same regional window, which under normal statistical conditions is the kind of thing that simply does not happen. And we covered the number that made scientists publicly uncomfortable, a 4.5 sigma deviation in the frequency of large, high-energy fireballs during the first quarter of 2026. For context, 4.5 sigma is the kind of number that, in physics, makes careers. It's the threshold at which you stop calling something a fluctuation and start calling it a signal. But here is the thing about signals. They only mean something if you're asking the right question. And for weeks, the question everyone was asking, including this channel, I'll admit it, was, what is happening over the United States? That was the wrong question. It was the wrong question because it was based on a reporting artifact, not a physical reality. The United States has the densest amateur and professional fireball monitoring infrastructure on Earth. The American Meteor Society has been collecting standardized reports since the early 2000s, and their digital reporting platform has been functionally stable since approximately 2016 to 2018. When fireballs happen over Ohio or Texas or Michigan, thousands of people with smartphones, dash cams, and sky monitoring apps generate reports within minutes. The system is extraordinarily efficient, which means that when a real anomaly begins, the United States is the first place you see it, not because it's happening there exclusively, but because that's where the observation density is highest enough to catch it first. Europe was already in the data. That's what the Brandenburg event confirmed. But before Brandenburg, consider what had already occurred across the Atlantic. On March 8th, a major bow-light event over Central Europe generated approximately 3,000 reports to monitoring networks. 3,000, which is not a number you associate with background noise. 3 days later, on March 11th, a fireball tracked across the France and Spain corridor, generating over 200 reports across 2 countries. 3 significant European events in 3 weeks. And yet, the narrative held that this was an American anomaly. It held because the data was arriving through different systems, being logged in different languages, processed through different national networks, and nobody had yet sat down and drawn the continental picture. The Brandenburg event on March 23rd was the moment someone finally drew the picture. And what they saw wasn't a cluster over one country. What they saw was a continental rotation pattern, large energetic fireballs occurring across a geographic footprint that spans the full width of Europe, rotating with the planet through whatever region of space Earth was currently crossing. There is a detail from the European data that deserves its own moment of attention, because it gets very little. Among the recovered material from elevated European fireball activity during this window, the American Meteor Society's tracking data flagged the presence of what analysts classified as potential HED meteorites. That's Howardite Eucrit diogenite, a rare class of stony meteorite that originates, as far as we can tell, from the asteroid 4 Vesta, or a body with similar geochemical history. HED meteorites are uncommon under normal conditions. Finding one is a notable event. Finding indicators of multiple HED class recoveries during an anomalous window is, and I want to be careful with language here, a data point that planetary scientists do not typically describe as coincidental. It suggests that whatever population of objects Earth has been intersecting, it is not compositionally uniform in the way a simple debris stream usually is. And then New Zealand happened. On March 30th, the American Meteor Society received a fireball report from New Zealand, which sits firmly in the Southern Hemisphere, far below the equator, and this single data point does something to the existing theoretical framework that I don't think can be understated. Every tidy explanation that had been quietly offered for the American surge depended, at some level, on the objects coming from a reasonably concentrated source. Meteor showers have radiance, fixed points in the sky from which debris appears to originate, because Earth is plowing through a stream left behind by a comet or asteroid on a predictable orbit. If you have a stream, you have a direction. If you have a direction, you have a hemisphere that gets hit harder. The New Zealand report breaks that geometry entirely. A debris stream narrow enough to explain a US cluster would not simultaneously produce Southern Hemisphere. Events with equal energy distribution. The physics simply doesn't support it. What the New Zealand event implies instead, and what scientists have been cautious but increasingly willing to say, is that whatever Earth is moving through right now is not a narrow stream. It is a diffuse, spatially broad population of objects distributed across multiple orbital planes, covering enough of near-Earth space to intercept our planet at any latitude, on any continent, during any rotation of the Earth. This is no longer a regional atmospheric event. This was never a local phenomenon. And the question that now replaces the old wrong one is both simpler and more frightening. What changed in the space around Earth, and when did it change? The American Meteor Society publishes statistics, and normally those statistics are boring in the best possible way. Year over year, the numbers that describe the near-Earth fireball environment are remarkably stable. Total fireball counts fluctuate slightly. Seasonal patterns repeat. Shower activity matches predictions. The background sporadic rate, the constant rain of random meteoroids that aren't associated with any known stream, stays within a recognizable band. Planetary scientists find this reassuring because stability in that dataset means the near-Earth environment is behaving the way orbital mechanics says it should. So when the first quarter 2026 report came out and analysts began describing a 4.5 sigma deviation, the reaction from the scientific community was not excitement. It was something closer to discomfort. Because 4.5 sigma doesn't mean more fireballs. 4.5 sigma means the distribution of fireballs has moved so far from its historical center that if you were to calculate the probability of this occurring by random chance, you would get a number so small it becomes almost philosophical. Here's what sigma actually means in plain language, because it matters for everything that follows. In statistics, sigma represents standard deviation, a measure of how spread out a dataset normally is around its average. 1 sigma means slightly unusual. 2 sigma means noteworthy. 3 sigma is what scientists typically call statistically significant, the threshold at which you start publishing papers. 5 sigma is what particle physicists required before they would confirm the discovery of the Higgs boson. 4.5 sigma sits between those two landmarks. It is, in practical terms, the number at which a scientist looks at a dataset and says, "This did not happen by accident." But here is the specific detail that makes the Q1 2026 deviation so technically disturbing, and this is the part that most coverage has glossed over. The deviation is not in the total count of fireballs. It is in the size distribution of the fireballs being observed. Normal meteoroid populations follow a predictable mathematical relationship between size and frequency. Small objects are common. Medium objects are less common. Large objects are rare. This relationship holds across decades of observation, and it holds because the physical processes that produce meteoroids, collisions, fragmentation, cometary outgassing tend to produce far more small debris than large debris, for the same reason that when you drop a plate, you get more small shards than large ones. The Q1 2026 data inverts this. Not completely, not catastrophically, but enough to register at 4.5 sigma. What the data shows is that the large fireball category, objects energetic enough to produce sonic booms, bright enough to generate 50 or more independent witness reports, substantial enough to survive atmospheric entry to lower altitudes, has disproportionately increased relative to the small fireball category. You are not seeing more sand. You are seeing more boulders. And that distinction is not trivial, because it means the change in the near-Earth environment is not simply more stuff. It is structurally different stuff. And structural differences in a meteoroid population are not generated by accident. Consider what this implies for the events we've already described. The Ohio detonation involved an object estimated at roughly 7 tons. That is a substantial mass for an undetected atmospheric impactor. The Houston meteorite punched through a roof, which requires a fragment of meaningful size and density to survive ablation and decelerate to terminal velocity before impact. The Michigan double event involved 2 separate objects generating simultaneous energetic entries in the same regional window. If the size distribution had remained normal, if large objects had stayed at their expected frequency, the statistical probability of these events clustering in a single quarter would have been vanishingly small. But the size distribution didn't stay normal. It shifted. And the shift happened across the entire first quarter, not during a single night of a known meteor shower, not in the window of a predicted cometary encounter, but continuously over months, in the background sporadic population that is supposed to be the most stable component of the near-Earth environment. There is another metric in the AMS data that supports this, and it is the one that has received the least public attention, despite being perhaps the most physically revealing finding of the entire anomaly. In approximately 79% of the large fireball events cataloged during Q1 2026, sonic boom reports were confirmed. 79%. Under normal conditions, sonic boom production requires an object to survive atmospheric entry to relatively low altitudes, typically below 40 kilometers, before either exploding or continuing to ground. Fragile objects, loosely bound cometary dust clusters, icy material from the outer solar system. These fragment and burn in the upper atmosphere. They are dramatic to observe. They do not produce sonic booms at the rate we are seeing. An object that reaches sonic boom altitude is, by definition, a structurally coherent object. It is dense enough, strong enough, intact enough to punch through the top of the atmosphere and keep going. Nearly 8 in 10 large fireballs during this period did exactly that, and nobody has yet offered a satisfying explanation for why the composition of the incoming population would suddenly skew so heavily toward dense, coherent, structurally robust objects. But the data says it did. One more number deserves its moment before we move on, because this one changes the orbital picture significantly. The AMS tracking data also flagged a 2.5 times increase in what analysts are calling long-duration fireballs, events in which the luminous trail persists for an unusually extended period as the object crosses the sky. Long-duration fireballs are produced by objects that enter the atmosphere at shallow angles, skimming rather than plunging, burning across a longer path because they are traveling more nearly parallel to the ground than perpendicular to it. The significance of this is orbital. An object that arrives at a shallow entry angle has a specific kind of trajectory, one that suggests it is approaching Earth from a geometry that differs from the standard sporadic background. If the number of shallow entry events has increased by a factor of 2.5, it means the geometry of arrival has shifted. The angles changed. The trajectories changed. Something about the orbital distribution of the objects Earth is encountering has changed in a way that produces more shallow, grazing entries and fewer steep plunging ones. That is not a compositional observation. That is a dynamical observation. And it points somewhere. We just don't yet know exactly where. There is a region of the sky that most people have never thought about, which is fine, because under normal conditions, there is very little reason to think about it. It sits in the direction directly opposite the Sun from Earth, the point in the celestial sphere that astronomers call the Anthelion. If you were standing outside at midnight and you looked straight up toward the precise point that sits 180 degrees from where the Sun is currently located below the horizon, you would be looking at the Anthelion. It is not a physical object, it is a direction. And under normal conditions, that direction is associated with a modest, stable, predictable trickle of sporadic meteors. The reason is simple orbital mechanics. Earth, moving through space on its orbit, tends to sweep up material from the direction it's traveling toward, which means the Anthelion, the direction it's moving away from, is a relatively quiet zone. The Anthelion sporadic rate has been measured consistently for decades, and it has been, by any reasonable description, boring, until Q1 2026, when it doubled. The American Meteor Society's analysts confirmed that Anthelion-associated activity during the first quarter of this year reached approximately 2 times the historical baseline. Not 2 times a slow week. 2 times the average calculated across every prior year on record. This is a significant observation for a reason that goes beyond the raw numbers, and I want to make sure this lands clearly, because it is, in the judgment of several researchers who have reviewed the data, the single most important clue in the entire anomaly. A standard meteor shower does not affect the Anthelion rate. Meteor showers have radiants, specific points in the sky from which all the meteors in a given shower appear to radiate outward. Those radiants are fixed by the geometry of the debris stream Earth is crossing. The Perseids radiate from Perseus. The Leonids radiate from Leo. And crucially, none of them radiate from the Anthelion. So when Anthelion activity doubles, it is not because a meteor shower happened. It is because the background sporadic population, the diffuse, sourceless, structureless, ambient meteoroid environment, has changed. Fundamentally, globally, across the entire sky. The implications of that are worth sitting with for a moment. A meteor shower is a localized phenomenon. Earth crosses a debris trail, gets pelted from one direction for a few nights, and then moves on. It's like driving through a patch of fog. Brief, predictable, bounded. A change in the sporadic background is something different. It means the medium that Earth is moving through has changed its character. Not in one direction, not from one source, but everywhere, simultaneously, in the diffuse ambient population that fills the space between the identified streams and showers. If the Anthelion has doubled, it means there is more material coming from behind Earth than there should be. Material without a clear source, without a radiant, without a parent body that anyone has identified. And here's what makes this genuinely strange, rather than just statistically unusual. There is no new meteor shower in the International Astronomical Union records. None has been registered. None has been proposed and confirmed. The activity that is causing these numbers does not have a name, because it does not have a point of origin that anyone has pinpointed. That is a scientifically uncomfortable position, and I think it's worth being direct about why. When you observe an effect without a cause, in a system as well characterized as the near-Earth meteoroid environment, it means one of three things. Either the detection and analysis systems have a flaw that is generating a spurious signal, and the AMS has checked for this, accounting for reporting infrastructure changes, and finding that the spike persists even when controlling for observation bias. Or there is a known physical process producing the result in a way that hasn't been correctly identified yet. Or there is something operating on the near-Earth environment that the current models do not adequately account for. The AMS data, as of the time of this recording, does not definitively exclude any of these three possibilities, but it has significantly narrowed the first two, which leaves the third option sitting there on the table, not confirmed, not ruled out, just waiting. The Anthelion surge connects to another finding in the Q1 data that, taken separately, might seem minor, but in context becomes genuinely thought-provoking. The AMS flagged an increase in high declination intrusions. That's a technical way of saying that more of the incoming fireballs during this period were arriving from steep angles relative to the plane of the solar system. Normally, most sporadic meteoroids travel in orbital planes that are roughly aligned with the ecliptic, the flat disk of the solar system where planets and most debris circulate. High declination objects arriving from steep angles suggest material that is not following standard ecliptic plane orbits. They suggest material from a population with elevated orbital inclinations, meaning objects whose paths cut across the solar system's plane at unusual angles. This is exactly the kind of signature you would expect if the near-Earth meteoroid population had been dynamically perturbed, if something had scattered objects out of their original orbital planes and sent them tumbling through the inner solar system from unfamiliar directions. Combine these observations, and the picture that emerges is not of a meteor shower or a debris stream or any of the tidy, bounded phenomena that planetary defense scientists usually deal with. The picture that emerges is of Earth moving through a region of space that has become, in some meaningful sense, different, more populated, more energetic, geometrically altered in ways that suggest a source population whose orbital distribution has changed. Imagine the solar system's inner region not as empty space with a few identified debris trails crossing it, but as a three-dimensional medium with density and texture. And now imagine that the density of that medium in the region Earth is currently crossing has increased, and the texture has changed, and nobody knows exactly why or when it started, only that the data is showing it clearly, and the trend is continuing. That is where the scientific understanding currently stands. And the next question, the one that the AMS data raises but does not answer, is what kind of event could do this to an entire region of near-Earth space? What could perturb a population, scatter material into unusual planes, increase the size of incoming objects, and do it all without leaving a single identified radiant or source body? Whatever the answer is, it is not something small. The official scientific position on the cause of the Q1 2026 fireball anomaly can be summarized in one sentence, and I think that sentence is more interesting than it appears at first glance. The American Meteor Society and affiliated researchers have stated, publicly and in writing, that the current anomaly is not consistent with a known cometary debris stream, but that disruption of the near-Earth meteoroid environment by a passing comet cannot be ruled out. Read that sentence again, slowly, because it is doing a lot of work. It is simultaneously saying, this is not what we usually see from comets, and a comet may have caused this. That is not a contradiction. It is not even ambiguity, exactly. It is a very precise description of a gap in current models, a place where the data points clearly toward a direction, but the theoretical framework has not yet caught up with what the observations are showing. And understanding that gap is essential to understanding why the situation we are in is as unusual as it is, and why the scientists who study this for a living are choosing their words with such unusual care. Let me explain what the standard picture looks like, because you need to understand the normal version before the abnormal one makes sense. A classic cometary debris stream produces a meteor shower. The comet orbits the sun on its long elliptical path, and as it approaches the inner solar system and warms up, it outgasses. It sheds material from its surface, releasing dust and rock that spreads along its orbital path over centuries and millennia. Earth crosses that trail once per year, at a predictable date determined by where the two orbits intersect, and we give the resulting display a name. The Perseids in August, from the comet Swift-Tuttle. The Leonids in November, from Tempel-Tuttle. The Taurids, spread across October and November, associated with the comet Encke. The material within each stream is compositionally similar, because it all came from the same parent body. The radiant, the point in the sky from which all the meteors appear to originate, is fixed, because all the debris is traveling in the same direction along the same orbital path. The duration is predictable. The intensity follows established patterns. The whole thing is well understood physics that has been characterized across decades of observation. None of that matches what we are observing in Q1 2026. There is no fixed radiant. We established that in the previous section, and it remains the single most diagnostically important fact about this anomaly. The material does not appear compositionally uniform, and here I want to bring back the detail about the HED meteorites from the European data, because it deserves more attention than it has received. Howardite Eucrit diogenite meteorites originate from a specific geochemical environment, most likely the asteroid 4 Vesta, or a body with similar formation history. Finding them during an anomalous window, arriving from directions inconsistent with a single stream, suggests that whatever population Earth is currently intersecting contains material from multiple source bodies, not a single parent. The duration of the anomaly has extended across an entire quarter with no sign of tapering, which is inconsistent with a stream crossing that should last days to weeks at most. And the global geographic distribution, 3 continents, 2 hemispheres, events separated by thousands of miles with no geometric relationship to a single radiant, makes a simple debris trail physically impossible as an explanation. So it is correct, and it is honest, to say this is not direct cometary debris in the classical sense. The data rules that out fairly cleanly. But here's the question that the classical model does not fully answer, and this is where I think the most important and underreported aspect of this story lives. What happens to the broader near-Earth meteoroid population when a large comet passes through the inner solar system at close range? Not what debris the comet itself deposits along its path. What the comet's gravitational influence does to the material that was already there, distributed through near-Earth space, minding its own business on its established orbits before the comet arrived. A sufficiently massive comet is not a passive object drifting through the solar system. It is a gravitational body, and gravitational bodies perturb the things around them. A large comet passing through a region of space where background meteoroids are distributed can scatter those objects, alter their orbital elements, change their inclinations, shift their eccentricities, modify the specific geometry of how they cross Earth's orbit. It can take material that was loosely distributed in a stable configuration and reorganize it into a new configuration, one with different size characteristics depending on how the gravitational perturbation interacted with different mass ranges, different angular distributions relative to the ecliptic plane, different contributions to zones like the Anthelion that were previously quiet. And critically, the comet does not have to deposit new material to produce this effect. It simply has to pass close enough to reorganize what was already there. The near-Earth environment contains a vast amount of background material in marginally stable orbits. A sufficiently strong gravitational perturbation could push some fraction of that material across the threshold into Earth-crossing geometry, and it would do so not all at once, but gradually, as the perturbed objects slowly migrate along their new orbital paths toward intersection with Earth. The effects of that reorganization might not appear immediately after the comet's passage. They might take months to manifest, which means that if a comet transited the inner solar system sometime before Q1 2026, the timing of the anomaly might not mark the comet's arrival in the inner solar system. It might mark the arrival of the consequences of the comet's passage, the delayed downstream effect of a gravitational disturbance that happened months earlier and is only now delivering its reorganized population to Earth's doorstep. There is a comet that reaches perihelion, its closest point to the Sun, on April 4th, 2026. That is 3 days from the date of this recording. The comet is designated C/2026A1, and it has been on approach through the inner solar system for an extended period before this moment. I want to be extremely careful with the language here because this is precisely where responsible science communication matters, and where the line between honest speculation and misleading implication is easy to accidentally cross. There is no confirmed causal link between C/2026A1 and the fireball anomaly. No published peer-reviewed study has established this connection. No orbital dynamicist has produced a confirmed quantitative model showing a causal pathway between this comet's specific trajectory and the observed changes in the near-Earth meteoroid distribution. What currently exists is a timing correlation. The comet's inner solar system passage coincides with the anomalous quarter, and a theoretical plausibility. The mechanism described above is physically real and not controversial in its basic form. A timing correlation and a theoretical plausibility are genuinely interesting. They are worth discussing and worth investigating. They are not evidence of causation, and I think you deserve to hear that stated directly, rather than implied around. What I can say is this: a comet approaching perihelion has been gravitationally interacting with the inner solar system for the entire duration of its approach. If those interactions had perturbative effects on background populations, you would not necessarily expect to see the effects peak at perihelion itself. You might see them build during the approach. You might be seeing them right now in the data from January through March, while the comet was still inbound. The word might is doing considerable work in that sentence. But It is the honest word to use, and this channel will always prefer the honest word. What is harder to set aside, and what I think deserves its own careful moment of attention, is the geometric relationship between the anomalous activity concentration and the trajectory of a completely different object, one that has nothing to do with our solar system at all. In 2025, an object designated 3I Atlas was confirmed as the third known interstellar visitor to pass through the inner solar system. The first was Oumuamua, identified in 2017, which generated years of scientific debate about its unusual properties. The second was Borisov in 2019, a more conventional-looking interstellar comet. 3I Atlas arrived in 2025 on a hyperbolic trajectory, meaning it came from outside the solar system, passed through, and is now heading back into interstellar space, never to return. Its path through the inner solar system traced through a region of sky that overlaps geometrically with the zone of enhanced Anthelion activity we have been documenting. Multiple independent analysts across different research communities have noted this alignment. The American Meteor Society and mainstream planetary science organizations have not confirmed any causal connection. The current official classification of this relationship is an unverified geometric coincidence, and that may be exactly what it is. But interstellar objects are categorically different from solar system bodies in ways that matter here. They carry material that formed under entirely different stellar conditions, different chemical abundances, different thermal histories, potentially different structural properties than anything produced in our own solar neighborhood. If 3I Atlas shed material during its passage, or gravitationally perturbed existing near-Earth objects as it transited through the inner solar system, the effects might not resemble anything our current models have characterized, because our models are built entirely on solar system physics. We have no empirical template for what interstellar perturbation of the near-Earth environment actually looks like, because we only confirmed that interstellar objects passed through here at all 7 years ago. We are, in a meaningful sense, working without a reference case. The recovered meteorites from this anomalous period offer one potential path toward a cleaner answer, and it is the path that the scientific community is currently most capable of pursuing with existing tools. Cosmic ray exposure age dating, the technique of measuring how long a recovered meteorite sample has been exposed to solar and galactic radiation, can tell researchers approximately when a given object was liberated from its parent body and began traveling independently through space. If the fragments recovered during Q1 2026 cluster around a specific and relatively recent exposure age, that would be physically consistent with a disruption event, a parent body that fragmented not in the ancient past, but recently, geologically speaking, scattering material into Earth-crossing orbits that are only now beginning to intersect our planet. The analysis takes time. The results are not yet available as of this recording, but when they come in, they will either support or contradict the disruption hypothesis in a way that no amount of fireball observation data alone ever could. The rocks falling through our atmosphere carry a chemical and radiological record of where they have been and for how long. That record does not lie, and it does not speculate. It simply reports what happened. The question is whether the pattern it reports, when the results finally arrive, will match any of the mechanisms we have been discussing, or whether it will point somewhere else entirely, somewhere that requires us to build a new framework from scratch. The sky has been showing us the effect. The rocks may finally show us the cause. Whether we are ready for that answer is, honestly, a separate question. The Ohio Fireball, the 7-ton object that detonated with the force of 250 tons of TNT, occurred over a state with one active all-sky monitoring camera in the relevant coverage zone. That camera was offline. Let that settle for a moment, not as a scandal, not as a conspiracy, not as the opening line of a thriller that ends with men in black suits confiscating footage. Let it settle simply as a fact about the state of our planetary awareness in the year 2026. One instrument, one state, one event, offline. The United States operates more fireball monitoring infrastructure than any other comparable geographic region on Earth. The American Meteor Society coordinates one of the largest citizen science networks for atmospheric event reporting anywhere in the world, drawing on dash cams, doorbell cameras, smartphone reports, and dedicated all-sky instruments maintained by universities and amateur astronomy organizations across the country. The system is, by global standards, genuinely impressive. And when the largest energetic fireball event of the year detonated over Ohio, the purpose-built instrument designed to capture exactly that kind of event was not functioning. The AMS has acknowledged this publicly and called for expansion of all-sky network coverage across the country and beyond. That call is worth hearing for what it actually says beneath the procedural language of institutional communication. It says, "We are not fully observing near-Earth space, not as a temporary gap that will be closed next quarter, not as a known blind spot in an otherwise complete picture, as a structural, ongoing condition of our planetary monitoring capability. The events we have documented during this anomalous period, Ohio, Houston, Michigan, the European bolides, the New Zealand report, are not the complete record of what occurred. They are what broke through. They are the fireballs that were loud enough, bright enough, energetic enough, or geographically fortunate enough to fall within range of a functioning sensor, or a population dense enough to generate reports. The question that no one currently has satisfying data to answer is how many events at similar or lower energy levels occurred during the same window, over oceans, over uninhabited regions, over the vast stretches of land where monitoring infrastructure is thin or absent, without a single instrument pointed at the right patch of sky at the right moment. This is where I want to address something directly, because this channel has built a community that takes these questions seriously, including the ones that sit at the edges of what mainstream science discusses comfortably in public forums. There have been theories circulating, some of them in our own comment sections, some on other platforms, suggesting that the fireball surge is not an observational gap problem, but a disclosure problem. That the events are being tracked by military and government systems with capabilities far beyond what civilian networks can offer, and that the true scale of the incoming material is understood by institutions that have chosen, for reasons of their own, to stay quiet while the rest of us piece together the picture from AMS reports and dashcam footage. The idea has a certain logic to it, and I do not think the people proposing it are being unreasonable to ask the question. Powerful institutions have withheld things before. History has an extensive and well-documented opinion on that point. But here's what I honestly think, having looked at this data as carefully as I'm capable of looking at it. The global distribution of the anomaly has significantly weakened the suppression hypothesis, not destroyed it, but weakened it in ways that I think are important to be honest about. A coordinated concealment of a genuinely global, multi-continental fireball surge would require simultaneous suppression across monitoring networks operated by different governments with different interests, different universities on different continents with different funding structures, citizen science organizations with no institutional loyalty to any state, and thousands of independent amateur astronomers across Europe, North America, and the Southern Hemisphere, many of whom upload raw data to public servers within hours of collection. The Brandenburg fireball was photographed by a civilian. The New Zealand report arrived through civilian AMS channels. The European bolide on March 8th generated approximately 3,000 independent reports from ordinary people who looked up and saw something bright and told their phones about it. The institutional coordination required to suppress all of that simultaneously, across all of those independent actors, in all of those jurisdictions, is not impossible in some abstract philosophical sense, but it is implausible in a practical operational sense to a degree that I think genuinely strains the hypothesis. The more uncomfortable version of this story And I mean uncomfortable in the way that things are uncomfortable when they cannot be neatly resolved, is that the problem is not hiding. The problem is knowing. The scientists and institutions whose professional purpose is to understand the near-Earth environment are looking at the same data that you are. They are arriving at the same conclusion. Something has changed. The effects of that change are measurable and confirmed, and the mechanism behind it has not yet been identified. That is not a cover-up. That is the frontier of knowledge, which is a less satisfying explanation in some ways, and a more frightening one in others. There is one more physical concept that this story requires before we can honestly describe where things stand, and it is the one that connects everything we have documented to a potential timeline that most public coverage has not adequately addressed. Debris streams and meteoroid populations are not uniform in how they arrive. When a parent body disrupts, when a comet fragments under tidal stress, when an asteroid suffers a collision, when a population of objects is gravitationally scattered by a passing body, the resulting material does not migrate into Earth-crossing geometry all at once. The physics of orbital mechanics distributes it in sequence. Smaller, lighter fragments, more easily perturbed by radiation pressure and gravitational nudges, tend to shift into Earth-crossing paths first. Larger, more massive fragments carry greater orbital inertia. They resist perturbation and take longer to migrate. This means that in the physics of debris stream evolution, there is frequently a sequencing effect. The lighter material arrives first, like scouts. The heavier material follows, on timescales that can range from months to years depending on the specific dynamics of the disruption event. Now, hold that concept against the size distribution anomaly we documented earlier in this series. The Q1 2026 data shows a disproportionate increase in large, high-energy, structurally coherent objects, not in small, faint meteors, but in the boulder category, the objects heavy enough to generate sonic booms and penetrate to low altitudes. If debris stream sequencing applies here, that size distribution does not necessarily mean we are at the peak of the event. It might mean we are at the leading edge of the heavier material that the lighter scouts already passed through, perhaps without sufficient monitoring infrastructure to be fully characterized. And what we are now seeing arriving in elevated numbers is the more massive population that took longer to migrate into our path. That interpretation is not confirmed. It is one of several possibilities the data is consistent with. The event could be tapering. It could be a bounded perturbation that orbital mechanics will normalize over the coming months as scattered material redistributes toward equilibrium. The data does not yet resolve which of these timelines is correct. But the question of whether we are early, middle, or late in this event is one of the most consequential questions currently attached to the Q1 findings, and it is one that only the Q2 data can begin to answer. The second quarter of 2026 is accumulating in real time as of this recording. April is already producing reports. The Anthelion zone is still elevated. The comet C/2026A1 reaches perihelion in 3 days, and the Q2 report, when it is eventually compiled and published, will be one of the more significant planetary science documents of this year. If the numbers normalize, if the sigma retreats toward background, if the Anthelion rate drops back to its historical baseline, if the size distribution inversion corrects itself, that tells a specific and relatively reassuring story. A perturbation occurred, it was real, it was anomalous, and it resolved. If the numbers do not normalize, if Q2 2026 shows the same distribution anomaly, the same Anthelion enhancement, the same global geographic spread, the same disproportionate representation of large coherent objects that tells a completely different story, one that would require a different class of explanation than anything currently on the table. I think you know which of those two outcomes would be harder to account for. And I think you know, if you have been following this series, that the trend as of the date of this recording has not yet shown any sign of normalizing. So here is where we actually are, stated plainly, without the framing and without the careful scaffolding of context. The American Meteor Society has confirmed a 4.5 sigma deviation in the near-Earth fireball environment during Q1 2026. That deviation is concentrated in large, energetic, structurally intact objects arriving from a global distribution of entry angles and geographic locations. The Anthelion zone has doubled its activity compared to every prior year on record. There is no identified radiant. There is no confirmed source. The anomaly spans 3 continents and at least 2 hemispheres. The detection infrastructure has known and acknowledged gaps. A comet reaches perihelion in 3 days. An interstellar object transited a geometrically relevant region of sky 5 months ago. And the official scientific position, the one produced by the people whose careers and reputations are built on understanding this exact system, is that they cannot rule out a disruption of the near-Earth meteoroid environment. That sentence was written by credentialed researchers. It appears in public communications from an organization that spent decades building the observational baseline that makes the current anomaly legible. They are not prone to dramatic language. When they decline to rule something out, it is because the data has not given them grounds to rule it out. Humanity has developed extraordinary instruments for observing the universe at scale. We have resolved the structure of galaxies billions of light years away. We have detected gravitational ripples from black hole collisions that predate the formation of our planet. We can characterize the atmospheric chemistry of worlds orbiting other stars from the surface of this one. The reach of our observational capability is, by any honest historical accounting, remarkable. And yet, in the first quarter of 2026, rocks fell through roofs, 7-ton objects detonated overhead with the energy of small nuclear weapons. Fireballs documented themselves over 3 continents, and the sky region directly opposite the sun doubled its historical output, all without a confirmed mechanism, all without an identified source, all while one of the dedicated instruments, built specifically to watch for this kind of event, was sitting offline in Ohio. The universe does not consult our monitoring schedules. It does not wait for the camera to reboot. And the distance between what we can observe at the far edge of the cosmos and what we can explain happening in the atmosphere directly above us is, at this particular moment in 2026, considerably larger than we are comfortable admitting. The question has never been what these objects are. We know what they are. They are rocks. What we do not know, what the data has opened without answering, what the next quarter will either clarify or deepen, is what changed. What changed in the near-Earth environment? What changed in the distribution of material Earth has been moving through since January. What changed in the system that the models said was stable, and whether whatever changed it has finished changing. That question does not have a clean resolution tonight. It does not have a satisfying final sentence. It has data that is still accumulating, rocks that are still being analyzed, and a sky that is still, quietly, doing something that no one has fully explained. That is where we are, and that is, if you sit with it honestly, a genuinely extraordinary place to be.